I'm Micah, and I'm here to talk today about migrating configuration to Kubernetes using ContainerTransform. And I'll kind of give a little bit of background first. For me personally, it's been a long road to get to Kubernetes. I've tried a lot of different systems, as probably a lot of people have. And I kind of wanted to give a little bit of history and context for kind of how everything is developed. So try to remember way back into 2013 in March. At a 5-minute lightning talk by a CTO of a small PaaS provider called .cloud, Solomon Hykes gave a demo, and it kind of rocked the developer world. The demo was just a really simple run a shell in BusyBox, small Linux container, but that idea kind of took hold really quickly. And so that was 3 years and 8 months ago, so not quite 4 years. So this, just to give context, this is really recent. Does anyone recognize this? This is, you might have eaten this for breakfast. This is Fig. And Fig came out not long after Docker did, about 8-9 months later. Fig was great. It was really easy to spin up multiple Docker containers when you wanted to run, say, in this example, like a database Postgres and a small Python app. With one command, you could turn on both and get them running and talk to them. Previously, you had to either use some shell commands or make files or whatever, run processes in the background, but Fig made things really easily, made things a lot easier. So June 2014, a lot of people are here for the reason of what started in June 2014, which was Kubernetes. Google open sources it. They open source it based on a lot of their experience with Borg and their internal schedulers. So that, again, is not that far away. That's what, just over 2 years. The next thing that I kind of want to talk about is November 2014. What happened then? Well, Amazon gets some skin in the game. They launched Amazon ECS, their EC2 container service, which, again, was a really great, even at the time, was a really great step up. Where Docker Compose was great for prototyping, and Kubernetes was pretty nascent. Amazon's ECS was actually quite simple to get to stand up a application behind a load balancer. Like, you could actually start serving something on the web, like very, very simply. So if you were using Amazon or had any experience with it, it was a simple start. So again, for context, November 2014, that's like a year and a half after Docker. So before we get too excited, I kind of want to back things up to 2011. 5 years old, right? Really old. Mesos comes on the scene and has initially just a few schedulers, Aurora being the chief scheduler originally. Since then, we've seen things like Marathon and Chronos by Mesosphere. And one of the great things about Mesos, if you've ever used it, is that you can even write your own scheduler. So if you're really need to be into resource management, for a long time, Mesos has been kind of a key player in that space. So fast forwarding again, September 2015. Anyone familiar with HashiCorp? They're the company behind Vagrant, Console, Vault. They released Nomad as kind of again, another scheduler cluster management system. So again, that's a year ago. That's really new. So along with all these we start to kind of see some diverging standards. Everyone kind of has their own, they call things sort of the same parameters, slightly different things, whether it's mem or memory or capital M and mem. They're all kind of have the same functionality or similar functionality, maybe slightly different, but they're all generally the same. So the next thing I kind of want to dig into is, there's all these different schedulers you can run things on, cluster management systems. I kind of want to look specifically at the configuration formats because I think those are interesting. Case one being Docker Compose. So if you ever played with Docker Compose, it's a really easy way to get set up. And here's just kind of a demonstration of an example of a Compose file. In this one, we have an Nginx container that's exposing some ports. It's linked to a web container. It's running a web app. It has a certain kind of memory limit, that kind of thing. Some environment variables, and then we have a database container in the backend. So this is really standard, right? I really do like Docker Compose. I think it's my go-to for when I want to prototype something and start getting something to work. I have numerous, maybe at least 20 GitHub projects that I've just okay, I want to try this element, I want to try Graylog, I want to try console, I want to try Vault. Create a Docker Compose, add some configuration files to it, and you've got something up and running. It's really awesome. And it just works. The other, I think, really easy part about Docker Compose is that it's easy to read. You can quickly see this and kind of understand everything that's going on. It's not that verbose. It has greasing defaults. The next case I kind of want to look at is Amazon's EC2 container service, ECS. If you've ever used it, you're familiar with this, but this is kind of compact JSON. But essentially, in Docker Compose, you don't have a top-level name for everything. It's just here are my containers. The top-level name kind of gets assumed based on your directory and on your laptop or wherever you're running that Compose file. In ECS, you have a family name. You can list some volumes, which Docker Compose now lets you do that. And then you just have essentially the same parameters. So yeah, that's cool. There's some that aren't there, you don't see links. Again, it's pretty straightforward. It's in JSON, so maybe a little less human readable, but still fairly readable. The third case being Marathon and Mesos. So for anyone who's used Marathon and Mesos, I will say the UI is pretty great. It's nice to have a heads-up display to see, okay, how many containers am I running for this service. And the service concept for those of you using Kubernetes is a little bit different, but this is kind of compact JSON of a Marathon of JSON. There's a lot more extra parameters, like forceful image. You specify the type of container, Docker, because Marathon has other container formats. It has its own, and I think it's now adding Rocket. CPUs, you specify the number there. You give everything an ID. You have to give some memory limits to everything, and you have to specify the network, that kind of thing. It does have some additional parameters. If you look, you see health checks, and that is actually, I think, just actually got merged into Docker, like a new health check parameter for an actual container. But health checks have been around in Marathon for a few years now. So you kind of get the idea. It's all the same, or it's very similar. And then the last case we'll look at really quickly, Kubernetes. This is YAML. For those of you using Kubernetes, you know that there's YAML config There's the same thing, just slightly different name or slightly formatting. So this is, I chose a deployment. I could have chosen a pod, but deployment shows just a little better. There's some more configurability. You have labels apply to everything, or apply to the deployment object, not just individual containers. And like ECS, you see volumes at the bottom, and there's a lot more. I encourage you to dig into the spec. There's a lot of really great knobs that you can change, whether that's health checks, readiness checks. So it's kind of stepping back for a second. So there's all these similar formats, but what are we, if you ever tried to switch from one format to another, one scheduler to another, say you have something on your laptop, you're playing with Docker Compose, you want to run it in Amazon or on Kubernetes. It can be kind of painful to have to copy and paste and indent and everything, all the configuration. So what does an engineer to do? Automate. So a couple years ago, when ECS first came out, I was, like I said, frequently used Docker Compose, really enjoyed it, and wanted to run these same things I was running in Amazon really quickly. And so the first format that I did was next slide, was Docker Compose to Amazon ECS. And this is a kind of compact version, but as you can see, there are required parameters for ECS that Compose doesn't support. So with this tool, ContainerTransform, we can now quickly pump out the runnable config for ECS and get alerted to, oh, you were trying to build with Docker Compose and you didn't supply an image. And Amazon's not going to let you build an image. You have to give it an actual image. So we'll see, we're missing an image. In this case, we're missing memory. The most recent addition to all this being Kubernetes, as well as a couple other formats. One is systemd units. If you ever used a tool by CoreOS called Fleet, it's very similar to systemd units. It's kind of been retired at this point, but back in the day, before Kubernetes really, Fleet was one of the early ways to try to run containers on CoreOS on multiple machines. So really quick, we'll do a demo. I made a couple. Yeah. All right. So. So we have a Docker Compose here, and basically it's kind of what I showed earlier. It's a really simple setup where a very standard web app. You'd have your Nginx container, you'd have a web app behind it, and you would have a Postgres database behind it. So you're prototyping your web app and you want to run it on your local Docker. But all of a sudden, you need to run it in you want to run it in Amazon. You want to try, okay, this is cool. Maybe I don't need an actual persistent disk, but I just want to see what does it look like to run in Amazon. And we have, we can just run ContainerTransform, and the default input is Compose, just because that is the most common, my most common workflow, and I think a lot of developers' most common workflow is to prototype something, run it elsewhere. And so you can really quickly see the output formats: ECS, Compose, systemd, Marathon, Kronos, which is another scheduler for Mesos that does cron background jobs, and then Kubernetes. So we'll just try, we'll do ECS first. So if we ContainerTransform, we don't have to specify the input type. The default is Compose, and then output to ECS. For verbosity, we'll just say that, Docker compose.yaml, we now have our almost runnable ECS file. There's, again, a few things missing. Memory. We didn't give it a family name, so we'll have to manually put that in. But again, say we want to run that. Okay, we ran that in Amazon. The next thing we want to do is say, okay, let's look at that. What does that look like in Compose? Or not in Compose, but in Marathon. And the default input file is just docker compose.yaml or standard in. So let's do that. Now we have a Marathon config for that same exact Docker compose file. And it's worth noting that in Marathon, you actually can't run groups of containers like you can in Kubernetes with pods. You actually have a separate service per container. I believe that's something that they're going to be adding in the near future, but for now, you can just run a single service has a single container. So this actually emits 3 different services.
How do you scale that?
What's that?
How do you scale?
With the individual service, you can adjust the number of containers.
The Marathon?
Mm-hmm. Yep. And so for one last example with this Docker Compose, ContainerTransform, output Kubernetes. So now we have our Kubernetes deployment. And it's worth, I'll also say, so right now I just output Kubernetes, but ContainerTransform also works in the opposite direction with any format, almost any format. If I'll run that help again so you can kind of see the input types and output types. There's right now, I think, there's just one output type that's not supported as an input type, and that's systemd. So say I wanted to run those on like a CoreOS box, and I dropped it in on the cloud config. If we set the output to systemd, we now have like a couple different systemd units, one for web, one for Postgres, and one for Nginx, and it will kill any existing Nginx. It will remove any existing Nginx, pull the correct image, and then run it, and then have the correct stop command. So that, again, that's only an output type, but say we, just for getting a little meta, say we have a Kubernetes config, right? So say this is our Kubernetes config that we generated, and we want to convert that to some, like you have an existing Kubernetes config, you want to debug it, run it on your laptop. So I'll just pipe this right into ContainerTransform and set input to Kubernetes and output to Compose. And that blew up. And that is because the Kubernetes is released in alpha, and I did not totally vet that yet. Okay, so in this case, we output as ECS. We'd output a Docker Compose as ECS, re-ingest it as ECS, and put it to, say, Kubernetes. So let's do that. So say you had an ECS config that you wanted to migrate, right? So here's your ECS config. Let's ingest that and send that to Kubernetes. Okay, we piped that in, and now we have a deployment for Kubernetes. It's not totally good to go. As you can see, like there's some labels that are null. We don't have a name for the deployment. That's kind of something that I'm not sure. I don't want to overload and add extra parameters to Docker Compose. It's not compatible with Docker Compose. I might add some extra command line arguments for that. So you can say a name for your output of whether that's your family for ECS or your deployment name for Kubernetes. But that kind of gives you an idea of the capability of this. So we'll jump back to the presentation really quick. And go back. All right. So I'll talk really quick about the internals. And the code, the project written in Python. And the basic idea is just that there's input formats and there's output formats. And then we also have kind of an intermediary format. And this intermediate format has, there's a lot of parameters that we saw that are, or not a lot, but a number of parameters that are unique to specific formats. So say for Marathon, it's fetch. It has a fetch parameter. So when you boot a container, it always fetches some file down into the container. For Kubernetes, it might be like a secret that you're mounting in, or a readiness check. Like there might be a health check in other formats, but a readiness check is a different concept. So what we essentially have is in the intermediary concept, or intermediary format that's not ever output. It just has a representation of all possible parameters. And so if there is an equivalent on the output format based on that input format, we'll try to emit it. If the output format has a certain requirement that the input format doesn't provide, we'll send out an alert and say, hey, you need an image, you need memory, you need something. And kind of with that, are there any questions you guys have? Yeah.
I had a couple questions. So first was, how is this, I saw there's another thing called compose with a K.
Mm-hmm.
Like what is the difference between these two? Are they kind of similar?
I've not really looked at compose. With this, it's really just Docker Compose or ContainerTransform is really just meant to be a developer side tool. There are, like I said, you'll see null values and things. So I try to do the least amount of surprising things and tell you if something's wrong, because it's not meant to run this actually in production. Like there's always some fine tweaking that you need to do. And so I believe Compose will try to run things in Kubernetes for you. That might be wrong, but
I don't know if
okay. Yeah.
And my other question was, actually not specifically about this tool, but
Mm-hmm.
I haven't used the Elastic container service
Mhm.
in Amazon yet. I thought that was Kubernetes based, but from what you showed, it looked like it was more based around Docker Compose than Kubernetes.
It is its own thing.
Okay.
It has similarities to Docker Compose, but it is its own format, and they actually have open sourced their agent that runs on. So with ECS, you have like a local agent that runs on your node that talks to your local Docker daemon and runs the containers and checks back in with the Amazon service and says, I can run tasks. Like, tell me what to run.
Kubernetes in the back end, it's not that.
It's its own service, yeah.
Okay.
It's not even Kubernetes, it's its own thing, their own implementation. And so similar to how you have pods, you have these task definitions which get run. And most of these different formats have the word service in it, like whether that's Marathon or ECS or Kubernetes. And so that actually leads to a lot of confusion. Kubernetes is the last of these things that I came to, the most recent. And so there was a big mental hurdle for me to be like, what is a service? Oh, service is just it has these labels, not this pod is a service. So yeah, there is confusion there, and ECS has its own idea of service as well. Yeah. Any other questions? Yeah.
Is there any roadmap for this to go even further around Kubernetes side?
Yeah. The original output format I did for Kubernetes was just a deployment, but one of the things I've thought about and haven't implemented yet, but would just be to say, okay, have a different output types for Kubernetes. Kubernetes deployment, Kubernetes pod, Kubernetes daemon set. Because there are different, you're right, there are different types of Kubernetes objects that you would like to run, whether it's a replica set or whatever. And for me, most of my Kubernetes things that I run are deployments, and so that made the most sense. But it's all like, the spec is actually almost the same. Go back really quick. There, yeah, that spec under spec template spec is pretty much the same across daemon sets, replication controllers and stuff. So if you needed to, you could kind of copy paste that, but that's a really good question.
Does it support service generation? Service
Not yet, no. Yeah.
That part should be got easy.
Right, exactly, because it's really just based on the labels. Since most other formats don't have a concept of like labels attached to that group of containers, most other formats labels are attached to a container. And so I didn't want to blindly assume that, say you had, say your Docker Compose had a label, had a Redis, and you had a web app. App equals Redis on your Redis, app equals web on your web container. Which one wins in that case, to apply it to the Kubernetes spec? I don't know. So I kind of left that to the user to decide. Again, it's not a total does everything for you, but gives you a good start to have to write a lot less output.
Yeah, the most interesting feature for myself
Mm-hmm.
right now is like the Docker Compose to ECS, because I have to work on some ECS project. That would be very interesting.
Yeah.
I mean, I had a hard time to consume that task JSON.
Yep. Yeah, we'll give it a whirl. Here's the links. I'll post this set of the slides on the schedule, but I have documentation for it as well as the project itself. And if you find bugs, file an issue, or if you have just questions about adding new features, please let me know. Last thing I wanted to say is thanks to my employer, Skuid, for sending me here, and Skuid is hiring, so if you want to work on things like Kubernetes and containerization of cool things, let me know. And thank you all for coming. Appreciate it.